Okay, here we are. We're going to do some special multiplication here, special products multiplication. Notice in this first column, what all of these examples have in common is that they're all binomials times binomials, and the 2 and the x, notice the first term and the second term match. The only difference between each one of these is the sign in between. Otherwise, these binomials match, but the signs are opposite. When that happens, there's a fast way to get an answer. You can do the full-blown distributive property, and what you're going to see is that every time when you have something in this form, for instance, this case, since the first term is an x, we will get an x squared. The second term is a y, we'll get a minus y squared. But everything else will disappear. So when you have this form, product of a sum and a difference, they call it, special product, you always get this quick answer, x squared minus y squared in this case. In this case, it would be 2 squared minus x squared, which we would write as a 4 minus x squared. This next one, 5 squared would be 25, then minus 2y squared, so it's a 4y squared, because the 2 has to be squared also. This next one would just be a 36 minus x squared y squared together. So you could go on and on like this indefinitely, doing these special products. So this is the fast way to do it. Now, this other one, this one resembles this form. If you expand it, you're going to see this. And if you were to do this the long way, the way we have to do most problems, the long way, we would end up with x squared plus twice the xy plus a y squared. And this pattern would repeat itself, and the pattern is that you have the x, you'd have x squared, you have the y, you'd have a y squared. And the middle term is going to be the product of x and y, in this case, doubled. And that will always happen. So for instance, in this next one, I'm going to get a 2 squared, which is a 4, and I'm going to get an x squared. The 2 squared and the x squared, they show up. The middle term will be the 2 times the x, but doubled. Just like over here, x times y, but doubled. So 2 times x is 2x, but when you double it, you get a 4x. And that would be our expression there. This next one, it works with negatives as well. You would have a 16, because 4 squared is 16, and we would have a plus x squared. Notice that the x, when it's squared, even though there's a minus in front of it, we still end up with a plus x squared. Now the middle, that's where the minus comes in, because we take 4 times negative x. We get a negative 4x, and we double it. That makes negative 8x in the middle. Okay, so the negatives are almost the same as the positives, except the middle term is a minus instead, but everything else is the same. So this next one, we would have a 36, because 6 squared is 36, and we would have plus 25y squared. And the middle would be 6 times 5 is 30, but you got to have a y there. So 30y doubled makes 60y. Now what makes this so easy is that most people can do this doubling in their head. So it's not a lot of extra work to do this. And once you practice this several times, let's say it was 7 plus 2x squared. For example, we would have 7 squared, which is 49. And then on the end, we would have a 4x squared. And in the middle, we'd have 7 times 2 is 14 doubled. Is a 28, and it's an x, because there's an x by the 2. Okay. Let's see. Here we can look at another example here at the bottom. Let's say we have 2y plus 3x. Let's make that x squared. So the whole thing is squared. So 2y plus 3x squared. Same routine. Square the 2y, makes it 4y squared. And on the end over here, we've got to square this 3x squared, so it'll be a 9x to the 4th, since you're squaring it. And then in the middle, we would have the product of these two terms doubled. So it would be a 6x squared y, but when you double it, you get a 12x squared y. And that would handle that. Okay. Hope that helps.